Welcome to Gastech 2025. We are here at the WIKA booth presenting our latest instrumentation innovations for the hydrogen and gas industry. One of the key developments is a new pressure transmitter concept that incorporates a hydrogen barrier layer. Traditionally, gold-plated membranes like what we see here have been used to mitigate hydrogen permeation and the associated risk of sensor drift. WIKA now offers an alternative approach, a thin-film pressure sensor featuring a newly developed hydrogen barrier layer. The new sensor design offers several advantages. It is more cost-effective, provides increased robustness, and simplifies installation by being compatible with standard pressure connections. Additionally, it enables full metal sealing and removing the need for elastomer O-rings.
Today we would like to talk to you about a new innovative solution called the TCC. What this sensor does is, unlike a standard thermocouple, which has a hot junction at the tip, this sensor has no hot junction and it can read the temperature, the highest temperature, along its entire sheath. We use it, among many other applications, to monitor the internal refractory wall failure. By reading the external mantle temperature, we're able to detect if there is any issue with the refractory wall inside. Whenever there is a refractory failure, you would get a higher temperature in a specific spot of the external mantle, and we call that a hotspot. This sensor is the perfect solution for monitoring hotspots, as it can read the highest temperature along its entire sheath. It can serve many other applications like thermal reactors, gasifiers, and many others.
What we are showcasing here is the WIKA Vibration Manager solution. Any rotating asset you have, be it an electrical motor, a pump, a conveyor, an agitator, we can retrofit it with our sensors. Thanks to the unique combination of temperature, vibration, sound, ultrasound, thanks to our long range, low consumption wireless technology, and to the artificial intelligence embedded in our platform, which is elaborating the data for you, we are capable of telling if the machine behavior is drifting from the regular one. We are capable of telling you whenever such an anomaly manifests, what kind of anomaly it is, what are the symptoms, and what are the possible root causes. So if your goal is to have your machine array up and running as much as possible and to optimize your maintenance operations, look no further.
What we are presenting here today is our gas density sensor DTG30, which measures density and temperature, and we have combined this sensor with a pressure sensor and a calculation unit in order to calculate secondary values which are very useful for combustion optimization or monitoring of fuel gas. Which may vary in terms of content and quality. So with these two sensors, we can get pressure and temperature compensated density, obviously, but we can also have specific gravity and the molar mass of the mix. And we can also calculate directly the gas proportion into the binary mix like methane, CO2, or natural gas, H2.
We are also showcasing our flow measurement solution with particular attention to our inline ultrasonic flow meter for gas. This device is also approved for custody transfer with a maximum uncertainty of 0.2% on the measured value. We have now also an engineering solution capable to measure pure hydrogen with an accuracy of 0.5%. Another interesting product we are showcasing here is the clamp-on ultrasonic flow meter for liquids. This is a new way to define the field instrumentation with a full color LCD, gesture control and also touch control. This device can also handle 4 pairs of transducers, and also it can measure on 2 different streams, so with one device we can have the work made by 2 devices.